Let's recall the structure of atom. So this is the structure of an atom. The central part of the atom is the nucleus. The nucleus consists of the neutrons and the protons. So the atom has the central part, which is the nucleus, and the electrons that revolve in the fixed shells or orbits. So this is the present accepted form of the structure of atom. Again, let's recall the masses of the three subatomic particles. So the mass of proton is taken to be 1 atomic mass unit. So with respect to the mass of proton, the mass of neutron is also 1 atomic mass unit. And the mass of electron is 1 divided by 1840 atomic mass unit. So here we see that the mass of electron is much less as compared to the mass of proton or the mass of neutron. One very important property of all atoms is their atomic number. So the atomic number is defined as the number of protons which are present in an atom. That is known as the atomic number, and it is denoted by the capital letter Z. So this is a very important property of all atoms, and the atomic number is the number of protons that are present in any atom. So let's see an atom here. So this is an atom. Let's count the number of protons. So the protons are depicted by the red circles with the positive signs on them. So if you'll see, we have 1, 2, 3, 4. So we have 4 protons in this atom. We know the atomic number is equal to the number of protons. So for this particular atom, the atomic number is 4, and we depict the atomic number by capital letter Z. So Z is equal to 4 for this particular atom. Another important property of atoms is their mass number. This is defined as the total number of protons and neutrons which are present in the atom. This is known as the mass number and is denoted by the capital letter A. Well, so this is the total number of protons and neutrons. Why aren't we considering the number of electrons when that is also an important subatomic particle of all atoms? Alright, let's see. When you go to buy fruits or vegetables, say you bought 6 kg of vegetables. And at times you ask the shopkeeper to give you some extra coriander. Does the shopkeeper weigh the entire vegetables again? No, he doesn't. Because you know that the mass of coriander is much less as the total mass of the vegetables that you buy. Similarly, the mass of electrons is much less as compared to the total mass of protons and neutrons. That is why when we consider the mass number, we neglect the mass of electrons and we take the total number of the protons and neutrons which are present in the atom and not the number of electrons that are present in an atom. So this is denoted by the capital letter A. So let's take an atom here. So this is the atom. Let's count the number of protons and neutrons. So the protons are depicted by the red circles. So we have 1, 2, 3, 4 protons and 1, 2, 3, 4, 5 neutrons. So the number of protons is 4, the number of neutrons is 5. We know that the mass number is equal to the total number of protons and neutrons that are present in the atom. So the mass number is 4 plus 5, which is 9, and we denote the mass number by the capital letter A. So A is equal to 9 for this particular atom. The mass number of an atom is 18. There are 8 neutrons in the nucleus of the atom. What is the number of protons present in the nucleus? So, we know that the mass number of an atom is equal to the total number of protons and the number of neutrons that are present in the atom. We are given that the mass number is 18 and we know that there are 8 neutrons present in the atom. So the number of protons that are present in the atom are 10. So there are 10 neutrons which are present in the nucleus of this atom. An atom is represented in this manner. This superscript A is the mass number of an atom and subscript Z is the atomic number of an atom. They are written in this manner or they are written on one side only. So again, the superscript is the mass number and the subscript is the atomic number. And this is the symbol of an atom. This can be for any particular atom. The capital letter X represents the symbol of that atom. Here we have an oxygen atom. Let's see how we can represent this oxygen atom. So let's again count the number of protons and neutrons that are present in this oxygen atom. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 protons and 1, 2, 3, 4, 5, 6, 7, 8 neutrons. So the oxygen atom has 8 protons, 8 neutrons. We know that the atomic number is equal to the number of protons that are present in the atom. This atom has 8 protons. So Z is equal to 8 for oxygen atom. Similarly, the mass number of an atom is equal to the number of protons and neutrons that are present in the atom. So we have the mass number equal to 8 plus 8, which is 16. This is represented by the capital letter A. So A is 16. So the oxygen atom, it has the symbol capital O. It can be represented as 16O8, where 16 is the mass number and 8 is the atomic number of the oxygen atom. So this is how we represent an oxygen atom. The number of electrons and the number of neutrons in an atom X were found to be 4 and 6 respectively. The atom can be represented as, so we are given that the number of electrons is equal to 4 and the number of neutrons in this atom is equal to 6. We know that an atom is electrically neutral. So the number of electrons is equal to the number of protons. This means that the number of protons in the atom is also equals to 4. The mass number is given by the total number of protons and the neutrons that are present in the atom. So we get the mass number equal to 10. The atomic number of an atom is given by the total number of protons that are present in the atom. So we get the atomic number of this element X as 4. So to represent that atom, we have X. The superscript is the mass number, which is 10. And the subscript is the atomic number, which is 4. So this is how we represent the given atom X. So let's calculate the mass number of any given atom. So let's add protons to this atom. So we have 1 proton here, 1 neutron. So we know that the mass number is equal to the number of protons and neutrons present in the atom. So we have 2, so the mass number comes out to be 2. Now let's add electrons to this atom. Still you see that the mass number remains 2. It is independent of the number of electrons present in the atom. So that is why we know that the mass number depends only on the number of protons and the number of neutrons which are present in the atom. Let's increase the number of protons and neutrons. So now we have 2 neutrons, 2 protons. So the mass number becomes 4. Let's increase 1 proton. So now we have 3 plus 2, 5. So the mass number of this atom is 5. So the mass number depends on the total number of protons and neutrons present in the atom. That are independent of the number of electrons present in the atom.